Chemistry is involved in everything we have around us. But studying chemistry can sometimes feel like learning a whole new language. Letters and numbers in what feels like something written in code. But the best thing is that once we figure out the basics, things will become more logical.
And for me, as a biologist, it's also important to point out that chemistry and chemical reactions are also involved in all of the natural processes that happens around us.
And everything starts with the chemical building blocks, the elements.
This is the chemical element and metal sodium. Whenever you're ready.
I'm ready.
And this is what happens when you put it in water. Sodium is, as you can see, really reactive, something that is pretty easy to predict when looking at its chemical structure. But let's not get ahead of ourselves here. Let's first take a step back and look at the basics. Everything around us, no matter what we look at, is made up of atoms, and all atoms have a similar fundamental structure. The core is composed of positively charged protons and is surrounded by an equal number of negatively charged electrons that move around the core in defined energy layers called electron shells. The number of protons in the core determines what type of atom we have. The sodium, for example, that we just had explode, has 11 protons. In addition, the core can also contain a varied number of neutrons, but these are, like the name implies, neutral and have no net charge. In total, there are around 100 different types of atoms, and we refer to these as the different chemical elements. So an element is something that is made up of only one type of atom, like for example helium gas, or like in our first experiment, the metal sodium. Different atoms can then bind to other atoms in different combinations and build countless types of molecules. Even if the differences between the different types of atoms is just a couple of protons here and there, these small differences are essentially what changes the chemical properties of the different elements.
Take fireworks, for example.
The way to achieve that awesome multicolored firework display is only possible because pyrotechnicians know how different elements react in different situations. Red color fireworks, for example, is the result of molecules containing strontium. Green is achieved from molecules containing barium. Orange is from calcium, and blue is from copper. Iron, on the other hand, is often used to create sparks. But chemical properties are of course not limited to the colors of fireworks. It could be all sorts of things. And one of the best tools we have to help us sort the elements and predict how they will behave is the periodic table.
The periodic table is a clever organization of all the elements, organized after how they differ in structure.
This is how it works. The number associated with each element is the number of protons in the core. Each row in the periodic table indicates a new electron shell, and the number of elements across in each row indicates how many electrons that particular shell can hold. The elements tend to favor having full shells, which means that they can either give off or receive electrons from other elements to achieve this. The elements in this first column, where we find sodium, all have only one electron in their outer electron shell. This makes them all highly reactive and prone to give off that electron to another element. So because of this, elements in the same column generally share similar chemical properties. All the way to the right here, we have a column with what is called the noble gases. Their electron shells are instead all full, which makes these elements extremely stable and not at all interested in taking part in any chemical reactions. And similar rules applies to all of the other elements as well.
It's almost mind-blowing to think that these close to 100 elements make up everything on the planet, from the mountains and the oceans to the genetic material that make up who we are.
The interesting and smart thing about the periodic table is that with just a little simple knowledge about its structure, and of course a little bit of basic knowledge about the elements, we can get a lot of clues to help us predict the outcome of chemical reactions, which is in turn what chemists use as the base for experiments and groundbreaking research.
Some knowledge about the chemical elements and how they are organized in the periodic table is key to understanding basic chemistry. For example, how and why elements bind to each other, why chemical reactions occur, and how we can synthesize chemicals, such as pharmaceutical drugs. And we have a whole series of videos to explore these topics more. Thanks for watching today.